This next example in 1.3 day 2 is about transformations. Last example we didn't actually use that word very much, but here we're going to go to the word transformations. We're going to use that a lot this year. So transformations on a basic function, again, you want to be looking at your 12 basic functions and use that as a reference. Use your book or print it out or whatever it might be. We're going to compare this function to its corresponding basic function. So we look at that and we have to figure out from the 12 basic functions which one it is. In this case, the most important thing is the fact that this is squared here. This is going to be a quadratic function, and so this is going to be transformed from y equals x squared. You may remember some of these things from last year as far as the different transformations that happen, but I usually like to start with the easiest ones. Easiest ones in this case, we've got x plus 4 in here, we've got plus 1 in here. Now, I think the easiest one is always this plus 1 on the outside. That just means that it went up 1 from the original. Usually the vertex on this one is at 0, 0. This one went up 1. X plus 4, that represents the horizontal shift. Now remember, that's kind of the opposite of what you might think. The way to approach this is to decide what value do you need to plug in there to make that equal to 0, and in this case it's negative 4. So that means that it goes to the left 4. Reflections. Reflections have to do with negatives, and so you'll notice that there is one negative in this problem, and it has to do with, well, this is the more common one. Every once in a while you'll see a negative on the x, and then you'll have to do a horizontal reflection, but for almost every case that we have this year, the negative will be on the outside of the function. If that's the case, then it will be reflecting over the x-axis. It's a vertical reflection for that one. The last part of this, at least for this basic one, is the stretch or shrink of y values. We're going to get to horizontal stretch and shrink later on in a coming chapter, but for now, the stretch or shrink of the y values has to do with the number out here. We're going to ignore the negative. That 3 means that it is a stretch by a factor of 3. So it's 3 times as tall as it would have been from the original one. In terms of each x value, it's stretched out 3 times what it would have been normally. And so again, this is something that you'll see on a couple of problems in your homework where you're answering these specific types of transformation questions.